Okay, I think we will start. People will join, then they will join. So, thanks for joining. This is Manny from Polygon Labs, live broadcasting from Canada. Still not 7 a.m. for him. So, thank you for joining. And he's going to talk with us about Polygon ID. You have the stage. And by the way, this is being recorded, just so you know if you have any. Let us know, so we can share it as well later. That's it. Yeah.
Awesome. Can you guys hear me just fine? Everybody, thumbs up. Yes. Yeah. There we go. Okay. I'll try to get into this presentation, and let me know. I can't. I'll mute you guys, but I'll start into this presentation quickly. So I just need to mute this so that we have the right audio going through. Okay. So let's jump into it. This is a presentation on Polygon ID. If you guys want to follow along, you can scan this QR code specifically for this presentation. So if there is any specific questions, or if you want to see the resources to this or whatnot and follow along, I do recommend that you scan this so that you can have all the links, all the resources, etc. for this presentation going forward. I'll leave it a couple seconds up there. So if you do want to scan it or get your phone out to be able to quickly scan it so you can follow along, I'll give you a couple seconds. In the meantime, I will just say buenos dias, bonjour, günaydın, good morning to everybody, or afternoon for that matter, for you guys. So as far as it goes, I'm happy to be here with you guys doing this presentation. So let's jump into it. This is an intro to Polygon ID. So we're going to be covering some core concepts, and then we're actually going to be jumping into some code specifically to be able to show you how Polygon ID kind of works. So there's going to be some examples, some code going over it, hopefully some Solidity code. It's not going to go crazy in depth, but going to give you the simple principles or the basic principles to be able to understand Polygon ID so that you can start working with it. And there's some interesting news regarding Polygon ID that's going to be coming up. So I really recommend, if you're on the ground floor working with Polygon ID as a platform, it'll be really interesting to kind of integrate with existing applications that any of you guys are building as well. So it's a great time to be able to start working on this. So let's just jump into it. A little bit about myself. So I'm Manny, or Coding with Manny on all my social platforms. You can follow me on Twitter. I'm a developer relations engineer for Polygon Labs in the Europe region. I realize I'm in Canada right now, but as far as it goes, I mostly do workshops or technical workshops or online office hours. We'll be in Paris and Lisbon, Berlin, and we'll also be in Denver coming in the coming weeks or whatnot, the whole Polygon team in that sense. So I've been in tech for probably 15 years. I've been a tech lead. I've been a full stack dev. I've done some DevOps as well, but I've done a wide variety of things. So I've got a lot of experience when it comes to tech. And in Web3, I've probably been native for about 2 years of working with specific companies. And I'm just really diving into Web3 in that sense. So give me a follow. I post tutorials and etc. on there so that you guys can kind of help you guys build along the way if you guys are builders as well. Just a small recap. This is actually a remix or a rehash of an existing presentation that was done by our other developer relations engineer named Steph. She's in the US. She did this presentation in Bogota. And if you do have a chance, and I recommend when you scan this QR code for the presentation, to give her presentation a good look. All the insights that really came from her as well. She did a great job. And this is my take on it and whatnot, but a lot of it just is building on the principles and the things that she put into this presentation. So, kudos to Steph for really helping out and really making this presentation awesome. So let's start off. Like, what information did I give you just about myself, right? I gave you a profile picture of myself, my job, my work, right now, my name, my social handle in that sense. But going into Web3, I want you to understand, or what I want you to question, like, how do we actually verify this types of information that what somebody is saying is true? Like, how do we go through the verification process? And I want you to keep that in mind while we're doing this, because this is the entire principle of how we do identity or have identity online, and how to verify that type of credentials. And to give you an example, we're going to jump into, just a scenario first to start with. So let's start off with SpongeBob, because SpongeBob is the greatest example for most presentations. Let's say SpongeBob is driving and he gets pulled over by the police. And let's see these officers ask him, please identify yourself and what's your name, right? SpongeBob, pointing to his work badge, says, well, I'm SpongeBob. It obviously says it on my badge, right? But in the mantra of Web3, we have this idea of not trusting what information that's presented to us. We need to actually verify it. So how do we know what SpongeBob is saying is true? Like, how do we, just his claim of being able to say, hey, this is my name, how do we actually verify that? And one of the main ways that we actually use this terms of verification as a principle is as like a driver's license. So, he pulls out his driver's license, presents it to the officers and says, hey, this is my verification of my name. Here you go. At least there's some sort of validation or proof that proves his statement about his name. But if you'll notice, if you're looking at this specifically, you notice there's a whole bunch of other information that SpongeBob gave to this officer. Where was the actual driver's license that was issued, what their address is, his physical traits, his birth date, dimensions, his gender, etc. All these things that are in this driver's license that wasn't requested of him, and really the only thing that the officer was asking for was his name. And this is actually a problem, specifically in the space today. We have too much information that's being shared with a lot of big tech companies, and they're hoarding it as much as possible. And really, it's obviously to sell you on ads and etc. But when we think about it, we're trying to just prevent bots and actually identify somebody as an actual human being to be able to use a platform to essentially give them value in the long term. So do most of these platforms need all this information about yourself? Probably not. They really need just the bare minimum to be able to actually create an account. But this is the issue that we're having, is that there's tons and tons of information that's being gathered from you to be able to create these accounts, because they ask so much information from you. So I'm going to just take a step back and kind of cover what the current offering is of the identity in terms of online identity space that's currently right now offered. So what we have is 3 segments or 3 different categories, right? One is centralized identity, so CI, federated identity, and SSI is a third option that we're going to be looking at briefly. So centralized identity, federated identity, and SSI. So centralized identity, you guys might be familiar with, is like you create your own application, or it's really an application that it doesn't do any single sign-on or any connections in that sense. So it's really like single purpose. So you think of like an app that just asking for your username, password, some personal information, but the characteristics of it are really, really siloed. And this is really what ends up happening, is that you end up using a password manager, and you probably guys have all like 50 passwords in one single password manager, because it's not really multiple. It's the same information over and over again over multiple accounts. And what you get from this is this idea of fragmented identity online. And one of the issues with this is that, let's say you signed up to 10 different platforms. And for example, let's say you get married and your name changes. You might actually try to go and update certain information on different platforms, but it might not be the case where you're going to go through everyone. And if you have a lot of these different types of systems that exist, there's probably hundreds in your password manager, and you're most likely not going to be going and updating each one to verify that the information is correct or up to date. And this is what kind of creates this fragmented identity as to what is actually the pristine type of data about yourself, and it just makes it a lot harder to manage in terms of centralized identity. The second option is federated identity. So this is like, it's not necessarily single sign-on, but it is a characteristic of single sign-on. So obviously I'm going to present this. So if you're familiar with like signing with Google or signing with Facebook in that sense, this is kind of getting at federated identity, but federated identity is a little bit more portable in that sense, that it's not just necessarily tied to one specific platform. If you want to know more information about federated identity and centralized identity, definitely look up okta.com and search up federated identity. So that's okta.com. They have full descriptions and full definitions about this. This is really, really interesting stuff. So definitely take a look. But getting at this idea of characteristics of, federated identity, it is multi-purpose. So in the sense that you have, like, if you sign in with Google, you save all your information with Google, and you're able to sign into multiple platforms with the, that one single source of truth. So it's very reusable in the sense that it's like portable in terms of multiple platforms. But one of the downfalls is that it's big tech that really owns your data, right? So in this sense, you're still giving that information away and letting them kind of manage it for you, which isn't necessarily ideal. And this is really, and this leads into the third option, which hopefully kind of covers this and handles this a little bit better, which is SSI, or centralized self-sovereign identity. Another way of calling it is decentralized self-sovereign identity. So it has all the perks of federated identity in the sense that it's multi-purpose, it's portable, but has additional benefits of being able to control your data and have it give you more power to be able to control that. So in other words, not using necessarily third parties to be able to do the verification like an OAuth server, but it creates this idea of using potentially zero knowledge proofs for privacy to be able to actually control which data is shared. And you might even be able to get to, and we'll dive into this a bit more, get into the concept of being able to share information about yourself or verify information about yourself without actually divulging or giving that information to a party or a verifier who's asking for that information. So surprisingly, this concept is not necessarily new. There's actually a book about this. It's quite thick. If you guys do want to find out more information about it, it's a book called Self-Sovereign Identity. But it really talks about the idea of empowerment of your data and actually having more ownership as to how you can control that specific data, and really just more power in your hands in terms of either a user or an organization as a whole. So it's a really, really great concept. And this whole talk on Polygon ID is really kind of is diving into this topic a bit more. So let's go back to SpongeBob in a sense, and let's talk about a principle that exists in self-sovereign identity. And there's this principle of a trust triangle, right? So there's this idea of a verifier, which is the police officer. There's the holder, or the person that needs to be identified, and then the issuer, the person that is going to give that certain information of proof. So in other words, exists this relationship where, hey, a verifier needs to ask, please identify yourself, SpongeBob in this case, the holder, who are you, etc. And he, like we saw before, we had a driver's license to be able to use that as a form of verification. And the driver's license comes from, in this case, Miss Puff, who from a boating school, who issues out these driver's license, and the verifier actually trusts them because they know that it comes from a reputable source. So we have their verified credentials that's given to the verifier, and it exists that triangle of trust in the sense in between each one of these in terms of that relationship. Okay. And this is where Polygon ID kind of comes in and solves this, implements this principle, right? So we have that trust triangle, and Polygon ID uses zero knowledge proofs to be able to make it more privacy focused, to be able to share and divulge information. So this is not necessarily new technology that exists. Zero knowledge proofs have existed for a while. This is like a platform that just makes it a lot easier for you to be able to implement these things or do these things. So that you can take advantage of that technology in a more user-friendly way, so that you don't have to create proofs, etc., and generate all these random mathematical codes to be able to do this information. It actually is all built in for you to make it a lot easier. So if we looked at the example of SpongeBob, let's use a real life example now of what that would look like with potentially Polygon ID. So in this case, we're using an example of a ERC20 token. This is called a on-chain verification process. Okay, and what that means is you have a contract in that sense who will perform a check for a zero knowledge proof in terms of a cryptographic proof that's generated to verify if you meet specific criteria to be able to, in this case, an ERC20 airdrop, to be able to mint it. So what that looks like is myself as an identity holder, I will actually get, similar to the driver's license, a claim or a credential that is coming from an issuer. In this case, we have a platform called platform-tests, and I'll give you the URL as well at the end of this presentation, to be able to create different types of claims. So you kind of think of it as like Miss Puff in this case, who is like divvying out those driver's license. In this case, we're doing a know your customer age credential to be able to verify, are you over a specific age, to be able to then actually mint these tokens. So the issuer gives me a credential in terms of a claim. I store that in a what's called a Polygon ID wallet, which I'll be demonstrating later. The verifier actually prompts me for that information, but it doesn't actually require what my actual age is in terms of divulging it. It just needs to know if it meets the criteria of over a specific age. And it generates a cryptographic proof, which is sent to the on-chain verification process, verifies that, and then from there, if it goes through, you're able to mint that ERC20 token and basically just process the transaction. So it's all this whole trust triangle process all over again without actually divulging any information, just verifying, hey, do you meet the specific criteria to process an on-chain interaction or on-chain verification? So we're going to jump into some code. And first, what we'll need is obviously the Polygon ID app. So I'll have that on my phone, and I'll be demonstrating how that works. I'm going to walk you through the process of creating a schema, creating a claim, or what we now call credentials, and being able to store that on the Polygon ID wallet, and then being able to use an on-chain verification process of being able to mint an ERC20 token if they meet the specific criteria of over a specific age, okay? What I will say as well, this is the platform test that we're going to be using. It will be, you'll see, if you're using this now, take advantage, because in a few days, this will actually be deprecated because there's going to be a new version, and there's going to be a slew of new features that are coming out for Polygon ID. So I definitely recommend, if you do have the chance, get onto this, get familiar with it, because there's going to be some changes, but the fundamentals will be there. This just makes your life a lot easier for getting started with it as well. So to start, I do want to verify, confirm with you guys that the Polygon ID app or Polygon ID wallet is not to be confused with like a crypto wallet, in the sense that, hey, I'm storing like cryptocurrencies like, Bitcoin or Ethereum or Polygon, Matic for that matter. What this wallet does is really just store your credentials or those claims that that's given from an issuer, and makes it a lot easier to create those cryptographic proofs. So let's jump into it. And so the first thing I'm going to do is I want to be able to create a claim. So I'm going to go here to our claim site, and I'm going to create a new schema. And what this does is like allow you to create like a template as to how the data is going to be structured, right? So that you can then use it for on-chain purposes, right? So, and what I will say is that there is a repo for this in terms of all the code. It's a mono repo, so it has both a contract and a front end for this. And we'll dive into this a little bit more, but it's simply the process of being able to mint an ERC20 token and then go through the entire process. So I definitely recommend, if you have the time, go through this README. It'll go through the entire process of deploying every aspect of this and going through the process of, getting that on-chain verification. And just to double check as well, this is actually an existing deployed contract. It's an ERC20 token with some additional functionality that we're just allowing to mint, but we need, in order to mint, you do need that cryptographic proof, that zero knowledge proof to be able to verify, hey, am I allowed to mint this? Okay, so let's start off by creating a schema. So I'm going to call this, KYC age credential. And I'm just going to copy this here. And what you'll notice is that there's, this is like case sensitive. And what we're going to do is we're going to create an attribute. In this case, we're going to call it date. The hidden name is date as well. And what I'm going to do is set the data type. Now, you'll notice that there's actually 3 different types of data types. There's true, false, date, number. And the reason why there is this, and there's going to be strings that are coming through too, is that when you're creating a zero knowledge proof, the idea behind it is there has to be a level of ambiguity, in the sense of like there has to be some sort of unknown in terms of a range. If I said to you, give me your exact age, then there really is no control in terms of your data. Once you give that over or divulge that, you're basically just, you've given it over. There's no control over it. Now, if I said to you, I just need to know if you're over the age of 18 or 20 for that matter, then there is a level of ambiguity. You can say, do I meet this criteria, yes or no? And if so, I don't actually have to divulge what my actual age is. I just say, hey, I do meet your specific criteria. And this is where numbers and booleans, et cetera, really come into place, and being able to say, hey, there's an actual range where you fit in terms of a criteria, and then validate that certain information. So in this case, we're going to set it to date. And one security feature that I really recommend is setting a mandatory claim expiration. So this means that like when a claim is created from this, or a credential that's created from this schema. So again, we're creating a template From that template, we're going to create a credential, which is then stored onto our wallet. And what we're doing here is we're saying that anytime using this template, we're creating a claim, we just want to make sure that there's an expiration date from that so that it expires. So you can think of it almost the same way as like, hey, we have a paper for a passport as a template, and we just got to make sure that on the passport there's an expiration date so that, you know, at one time it actually becomes invalid. So I'm going to first just save the schema, and we'll see that under KYC credentials. And what I'm going to do here is now issue that credentials to my Polygon ID app. So I'm going to go in here in my KYC age credential. I'm going to set the actual date. So let's go maybe not to the 1600s, but the 1900s, January 1st. I'm going to set the expiration. So we saw that before, setting a mandatory expiration date. And that's what we're doing here is we're just going to say, hey, this is going to expire on February 28th. So next step is we're going to create some criteria for this claim link. So one of the things is we're going to add this to our phone, but we want to make sure that, you know, not anybody else can then scan this. And we just want to make sure that it's valid for a specific time. So maybe to the end of next week. And we also want to make sure that it's only issued once. So similarly, like let's say you had a template for a passport and you have it, you don't want that template to be used all the time. If it's like, hey, I'm going to give it to this one user, they don't claim it within a certain period of time, I need to be able to redo it. And I want to make sure that I only issue it once and not a duplicate for that matter. So let's create a claim link. And then from here, I'm going to go preview claim link. Now, I will say that this takes a couple seconds, but I will show you what this looks like in terms of my phone here. So the first thing I'm going to do, I've opened up my Polygon ID app. And what I can do here is I can see that there is no claims or no credentials that are stored in my Polygon ID app. So the first thing I'm going to do is I'm actually going to connect to this site. So you'll see it here. I'll connect. I'll enter my super secret password, and it's going to authenticate. Now, the authentication process takes a couple seconds. We're working through this to kind of speed up the process as well, but it'll do a two-step process, which is authenticate, so connect to the actual site to verify that, hey, that you can actually, that there's an established connection between it. And then the second part, which will be to actually prompt and store the actual claim on the app, on the wallet itself as well. So it does take a couple seconds, and I realize that it does look like it's, you know, it might be broken, but it actually does take a couple seconds to be able to connect to the site. And there we go. So I've been authenticated, and you'll see that the page will refresh in a second to be able to store that claim. Yeah, so it just refreshed, and now we see that the KYC age credentials has been updated, and now I'm going to add this to my phone. So you'll see that now it's been prompted as the credentials. I accept it, enter my super secret password, and then I'm going to add the claim directly to my phone. So in the wallet. So now if we looked at it, the wallet specifically, we'll see that that claim exists, KYC age credentials, and we'll see that the date was January 1st, 1900s. And the expiration is for February 28th, 2023. So at the end of this month, basically. So we have it now stored. So now we got to go into our actual code, and we're going to jump into what that ERC20 contract looks like to be able to show you how you can do the minting process. So let's jump into our code here. So again, this repository is available and all the steps. It is a work in progress of the README, but if you do have questions, definitely hit me up on Discord or Twitter to be able to, if you have specific questions or get stuck. But most of the steps will be here in this specific README of this code to go through the process. So I'm just going to increase the the size so it makes it a little bit easier for everybody to watch or to see. And in this monorepo, there is two folders for this. This is the contract, and then there's the front end for that matter. So the contract that we're actually deploying is a ERC20 token. So it is a standard token. Everything is just borrowing from OpenZeppelin, ERC20 as a template for that matter. But we'll notice that there's a few different additional functionality that's been inherited from another Solidity file, which is called ZKP verifier. So this functionality allows us to be able to set the actual zero knowledge proof, to be able to understand how a proof is submitted and be able to do that verification process. So we're going to do two steps with this, which is one, hey, we've updated this is the information. This is how our template of the schema that we made. And we want to make sure we're updating that on this contract to say, hey, this is how you should interpret it to meet a specific type of criteria. And then from there, there's the actual submit of the response. And what that happens is you have, once the submit for the response is called, what happens is it goes through, does the verification of that actual proof. And then what it does is it performs a hook called after proof submit. And what we'll see is here in the main contract, the after proof submit, it goes through the process of verifying that you have not minted this before. And then what happens is it just goes through and mints you 5 tokens essentially, which we'll see here as the default for 5 tokens specifically. So again, high level, really it's just, hey, we're setting a format to be able for that contract to be able to interpret some things, and then from there be able to submit the response when the actual user is, verified their credentials in a specific way, so that, hey, they can actually mint the tokens. So the one thing I need to do here is, because I have a contract that's deployed, but I need to update it with the information of the schema that we just set up. So I just need to update a few different environment variables. The contract has already been deployed, and the validator address, this is actually quite important because Polygon ID is currently only working on Mumbai, but it will be coming to mainnet. What this does is that the validator contract is a way to be able to check if a claim is still valid. So it does a last minute last minute check to be able to check if, hey, if this transaction still valid and should go through, and this shouldn't change as far as it goes. So there will be one for mainnet as well, but as far as it goes, this is the actual validator contract that we'll be using. And we'll notice that it's on Polygon Mumbai, the chain ID obviously, and the method, this is actually a hashed name of the method for submit CKP response, which we'll be hitting. And we'll notice that the required attribute is the date. So that's the attribute that we set before. So if we went back to our Polygon ID here, platform, we'll notice that under here, this is our attribute, which we set to date. But you'll notice that there's actually 2 different attributes, and this is the maximum you can allow, is like two different types of attributes you can verify for. You'll notice that in here, it says slot index. And slot index 2 refers to actually attribute 1, and slot index 3 refers to attribute 2. So just have to remember that it's a little bit, the index is a little bit off by 1, but that's what you're saying, hey, we're going to be checking for this specific attribute on slot index 2, which is our date. And what we're going to do is we're going to say, hey, it needs to be less than, and there's a few different query parameters for this, or this ZK query language that you can kind of take advantage of, where it says it can be greater than, less than, within, or not within. In this case, it's saying less than, and it needs to be less than 2002-001, so January 1st in that sense. So what we're saying is that the requirements of this schema is that somebody needs to be older than the year 2002 January 1st for that matter. And less than means obviously that number is less than, which means that they're older. And we're going to replace the schema ID, which we just created from the schema specifically. So went here, and this is KYC credential. And we're going to copy the schema ID here. And we're going to copy the schema hash, which is needed. And we're going to copy the schema URL. And we're also going to double check that the naming conventions for this as well have been set correctly. So I did a typo last presentation. So KYC H credentials, that matters. So we've set that, and what we're going to do is we're going to run a script called submit set ZKP request. So this is, again, setting all the values like we mentioned before for the contract to understand and really interpret the schema in a specific way. So it's specific, it's looking for a specific proof, it's looking for that date attribute to be able to verify if that's actually true. So what we're going to do here is we're going to actually make that change to the contract itself. And let me just double check here. Under package, it is yarn set ZKP request. Once that goes through, we should see a transaction. Give it a second. There we go. I'm so happy that everything is working on contracts right now, or live right now. So sometimes these demos cannot always work amazingly. So I'm happy that this is actually working properly. and there's no connection issues. Okay, let's just refresh this. This usually takes a couple seconds to make sure that the transaction goes through. So it's successful. So we've submitted our ZKP request. So again, the template of how the contract interprets these zero knowledge proofs. And then the other thing we're going to do is, because we've already set up these environment variables, it's already set up for our front end, which we'll see here under node 1. It's just a VJS React app that shows a specific QR code, and we can see that here. So you'll see that the contract, that's the contract that we had deployed, and this is the set ZKP request that we just performed. So to be able to interpret it, and now it has all the same criteria of the less than, greater than, and we're going to go through the process of actually minting an ERC20 token through that verification process. And if you ever want to debug this, I did create a section where it shows you all. This is the actual JSON that's stored within this this QR code, so you can kind of verify this information as well. You'll notice that the required attribute is date, and it needs to be less than 2002-001. So all that information is set. And if you want to dive deeper, there is specific. I go line by line in each one of these files to be able to really dive deeper as to what each one of these attributes are. So you can definitely here under proof request. So this is the default schema. You can go line by line and explain each one of these so that you can kind of have a better idea of what is actually going on underneath the hood. So so I'm here. So I'm going to bring up my app again, and I'm going to go through the process now of being able to do my verification check. So I'm here in my app. I'm going to scan this QR code again, and I hope everything works here. So it's going to check for a proof request that exists in my wallet. It says generating proof. So it's there, like I've generated, it's great. It's recognized that the claim or the credentials exist in there. I'm going to enter my super secret password, and then it's going to connect to MetaMask in this case. Oop. And from MetaMask on my phone, it's going to connect to this site to make sure that it can actually process the transaction. So here we're generating the proof, and we're going to give it a couple seconds, going to switch back. And what it's going to do is prompt me to actually process the transaction. So once it goes through, that's done. And then here we can actually see the transaction. Let's hope everything has gone through. And we can go view history. Oops. Here we go. And we go to the view on Mumbai. Give it a second to process. Oops. Here we go. Perfect. And it went through. So what we're going to do is we're just going to copy the contract address. And then from there, I'm going to go back to my wallet, and I'm going to import specific tokens from a specific address. And then it'll autofill because it'll pull that information from here. So ZK ERC20 token, which we saw before in the actual code. So here under our contract and under ERC20 token, you'll see that the name is set to that we set actually when we did the deployment to ZK or ERC20. And let's just switch back to here. I'm going to import, and then it'll update, and you'll notice that there's 5 ZK ERC20 tokens that were minted. So we successfully submitted a proof. We verified that our age was over the age of 2002's January 1st, which it was the case. And then from there, from the proof request, once it's actually validated, we were successfully able to mint that ERC20 token directly into the app, into our wallet, basically. So let's back at this. In total, this is the entire process of being able to perform. There's a lot of different possibilities to do with Polygon ID and what you can actually build on it. But as far as it goes, there's I definitely recommend looking at all these different resources, which again, I'll post with the QR code. You can scan this QR code to kind of go through this yourself. Some of the applications I've seen is like people creating either health benefit, like health apps where people can actually submit personal information about themselves without actually divulging their identity to help science. I've also seen examples where people have done, hey, how do we do loans in a way that we can actually verify someone's like income, but not actually divulge who they are to kind of prevent, again, discrimination, so that people can actually, get loans based on the criteria in terms of just how much income they actually make to be able to get them approved, and not by other criteria for that matter. So there's a lot of different things you can kind of do, but really this introduces, I find this really exciting because it's really introduces the idea of really owning your data and really having more control over it and divulging only what you need to, and verifying information in a way that's super, super private in that sense too. So that is Polygon ID. And I will open the floor up, obviously, for questions as well. So, well, okay, so how about I'll give some examples of questions that I've gotten before. Is if somebody can be, one question that I always get is, if somebody can be an issuer, can anybody be an issuer in that sense, right? If we looked at that, that triangle of trust again, where is it, right? Who can be an issuer in that sense, right? Like, how can you trust a specific issuer? If you can be your own issuer and you validate your own information, it's like, okay, I'm just patting myself on the back in that sense. Like, how do we trust that? It's not really verifiable in that sense. So what you have to remember is that Polygon ID is like a platform. So anybody can be an issuer. But what you can do with on-chain and off-chain verification is be able to specify, hey, I trust these specific issuers, and whitelist them essentially, and just say, hey, only these people I actually trust. So an example would be that, let's say a government, is an issuer, right? And then itself, a verifier might be, you go to a border services in another country, and they want to say, hey, I want to verify that you are from an eligible country that comes into the country for the visa. Then I would say, hey, I trust this specific issuer in terms of this government, right? Whatever information that's coming through, you are valid, you're valid to have a visa to come into this country, but I don't share any information about you apart from, hey, do you meet the criteria to be able to enter this country? So you can say, technically anybody can become an issuer, but really you have the choice as a verifier to be able to say, hey, I only trust these specific issuers for the credentials that essentially is being shared. Another question that I typically get is, well, what happens if you lose your phone, or, what happens if you just lost that credential in that sense, right? Well, similar to a passport, if you lose a passport, you basically have to go get a new passport in that sense, right? So if you think about it, there's a little bit more added security so if you think, we actually have a service also with Polygon ID through another third party that does KYC, where you can actually submit your passport and get that information back as a verified credential through a verified source, right? So, but there is some added benefits. Like, if you lose your passport, somebody can essentially take it and maybe even start, using it. The only way that you can actually prevent yourself from getting abused for identity is that you actually have to contact your country and say, hey, this passport has been stolen. Whereas Polygon ID, what you can do is there's a few different ways that you can invalidate or make sure that the credentials are still valid. And one of the ways that you saw, which is the simple way, which is like that password that's on your phone to be able to access those credentials. So similarly, when we enter that super secret password of 1, 2, 3, 4, 5, 6, that's a way to prevent somebody actually accessing the credentials. 2, the second layer is, hey, you have a password on your phone. 3, like we mentioned before, for those claims, we actually set an expiration date for those claims. So, hey, it's a certain period of time. If it hasn't been used, they will expire. So they actually can't be used for other credentials. And 4, the last way that we actually verify added security is the actual issuer can actually invalidate a claim as well. So there's still, from a verifier point of view, there's still a last-minute check that goes to the blockchain and says, hey, is this claim still valid? No information is stored on the blockchain apart from the claim ID, the unique identifier. And it still performs one last check. And that's where we saw that verifier contract that has to not be changed within it to be able to say, hey, is this still valid? And the issuer can actually invalidate it and say, hey, like, this is no longer valid. It shouldn't be considered. If all the information is correct, it should be an invalid piece of credential. So there is different varying levels that kind of help you to be able to safeguard your information even further and make sure that that information also becomes expired, so it's not abused in different ways too. I can hear you very briefly. Shira, I might have to ask you to repeat the question if that's okay. Come on down, ask these questions.
Hey, Better now?
Yes.
So I've checked, for example, other solutions that do this in a certain way, such as Web3 auth. And so my question is, do you have a way to implement this on an already existing app, making a process, like a seamless process for people to create those credentials in-app already?
Yeah, so what we saw here was like that platform test website that allows you, again, it's all on Mumbai and testnet, but it's going to be released on mainnet very soon. So there's what I showed you was called an on-chain verification. There is the issuer process. There's a repo for this specifically. Let's see if I can bring it up here. X Polygon. So all these tutorial examples are a claim schema, being able to be an issuer protocol for that matter, doing the on-chain verification. There's also one that's in the GitHub Polygon ID docs, which shows you how to do off-chain verification. So what I mean by that is you saw an example of like a verification process that's done through a contract on blockchain. But there is ways to do that for native Web 2 applications. So if you wanted to do something like, hey, sign in with Polygon, right, where the idea we're trying to create as to generate a zero knowledge proof, you can do that where you don't actually have to use a contract. You can just use a front end that works with it to be able to do that verification. The only thing that you need to make sure is that in that off-chain verification process, it still performs a check to the blockchain. So you'll need like an RPC request to be able to just perform, hey, is this claim still valid? But the entire process is, hey, I'm just going to verify certain credentials with you on a regular website. So there is UIs, like I mentioned before, like the platform test, and there's going to be some new ones to be able to kind of create the issuers. And then there's all these other tutorial examples, including the one that I showed you in terms of that front end, which we saw today, as being able to process this. So this can be done in a different way to be able to generate these QR codes to be able to get somebody to log in. We just did, hey, we're going to do a minting process, but the other process for this would be, hey, I just need to access this site as well using Polygon ID. The nice thing about this is, like you mentioned before, Web3 auth. Web3 auth uses social logins, right? So some getting at the idea, hey, I'm using Google, sign in with Google or sign in with Facebook to be able to share that information. Where this case is, you own that. There's no other third party, and you're creating zero knowledge proofs to be able to prove certain information about yourself. So no information is exchanged. But we are going to get to this new features, which is going to be exciting coming up in the next month or so. Hopefully, where you'll be able to do some more interesting things with it. But really, you don't have to share any information you don't want to. So hopefully that answers your question.
Question regarding the information, because if I understood correctly, you choose what information do you share. Is that correct? It's the basic principle. You can see I'm going to share this or this not. But my question is, what happens when you are when you have to share mandatory information and you have to prove that you are a human on top of, let's say, 18 years old, because you are going to access certain websites that you need to prove that you are a human with certain characteristics. This is possible with your project, or this is possible to link this project, like, I don't know, Proof of Humanity. This is another DAO that is.
Yeah. So let's use the example of Proof of Humanity. That might be a good. So how would you prove somebody is human? Out of curiosity. All right. Well, maybe an example or maybe a quick way to do it is like, let's say you open up a webcam, an app for that matter, and then it just scans your iris in that sense, and you're moving left to right, and you're showing, hey, I'm an actual human on a webcam for that matter, to be able to say, hey, you followed instructions and you're an actual human being, right? So maybe they ask you to do a TikTok dance or something, right? So that might be a way to be able to do a verification process, to be saying, hey, you met this certain criteria, almost like a CAPTCHA, like you followed steps and we verify it. So the nice thing about this platform is that as an issuer, you do whatever steps you want to be able to do the verification process. And then from there, you then decide to issue a claim or issue a credential that says that they meet that specific criteria, right? That can be used on whatever verifier platforms, right? The nice thing is like, hey, you know, like you might say, hey, I want to prove that you're a human. And, you know, maybe some criteria that some of the information that you're stored from the webcam is like, oh, your eyes are brown. We can recognize that, you know, you might have long hair. You might have a specific ethnicity that just automatically detects whatnot on this video. And all that information is stored to be able to say, hey, these are the criteria of you as a person. Same way that we have a driver's license that shows, you know, hey, this is my weight, this is my height, you know, etc. You know, am I wearing glasses? Yes or no? So all that information can be stored. And what you could do is you could create a claim from that and then give that to the actual holder. And then if they need to verify that information, right, you're just like, hey, we need to know that people with green eyes only can access this site. You can say, well, or has any type of eye color for that matter, then verify that information. The verifier just says, I trust whatever issuer you did to be able to prove that you're an actual human because you just met that criteria. But you didn't release any information about yourself. You're just saying, hey, I met that criteria. But what you did get at, which is really interesting, is which will be coming soon, is the idea of divulging certain information if you did want to. So everything about this platform is about privacy, right? So I have all this information about myself, and I can just say, like, are you a human being? Yes or no? But you don't know any information about me, right? Do I just meet that criteria? Yes or no? Am I over the age of 18? Yes or no? Right? You don't know my age, you don't know my name, none of the other information. Do I meet just your specific criteria? And that's where zero knowledge proofs come in, is really to be able to have that and not divulge too much information about yourself. But you can later on, which we're going to be getting into, is the idea of like, hey, maybe you want to do selective disclosure or selective information that you do want to share with those sites, because maybe they want specific information from you as well. But that's, again, giving you more power to be able to decide what information you actually disclose, and still hitting to that privacy, which doesn't necessarily exist on most platforms. But again, you can create whatever issuer verification process and create an issuer to be able to prove you're a human for that matter. This is just an easy way to be able to make it, or facilitate it and make it a lot easier to work on Polygon ID. I know this is a lot of information. So like here, there's tons. We'll be doing a recording of this as well. I'll try to do as much support with the team. And there's obviously guild leads as well, obviously in Madrid. So if you guys do have questions, and definitely hit me up on Twitter, definitely hit me up on the Discords, etc. There is the Polygon Discord as well that we have specifically for us, and we're going to be doing more office hours. So if like, hey, if you're stuck on a piece of code or something doesn't make sense or whatnot, come into the office hours, which we're going to be doing weekly. And you're like, hey, how do I do this, or how can I implement this? And we have a pretty good team of wide variety of different backgrounds, from like really strong smart contract developers to full stack Web 2 native to just a wide gamut, and also people from DevOps. So as far as it goes, we'll be trying to come in and help you guys out along the way. Really, I would say that if you wanted to start somewhere, go through this tutorial of that README that I showed you guys. Just follow the steps and see that process. And again, let me just all this process, go through it. It's in the links of the description. Go through this, look at it, and somebody who always adopts new technology, follow the steps, really understand how that's going through, how you're able to do that. Change things up. Instead of an ERC20 token, make it an NFT. You know, if it's not an NFT, make it a multi-sig, right? The nice thing is you just kind of add it to it. And then if you really want to dive into, you know, I want to know more about how to set up off-chain verification, there's things like that in terms of to be able to go through the entire process too. So this is also a way to be able to do that native Web 2 applications, to be able to have more privacy focus and more control over your data too. So again, all these links, etc., are in this presentation. Take out your phone, start scanning this if you haven't done so already. And again, I'll be around if you guys need any help with this too. Any other questions?
Thank you.
Yay! Muchísimas gracias a todos. And again, thank you guys. I know it's early for me, but I hope you guys enjoyed it. So Take it easy. Ciao.